In this video, I'll talk about word problems involving permutations and combinations. So the first thing you need to understand is the difference between a permutation and a combination. In a permutation, the objects that you're talking about, the order of those objects matters. So for example, you might be talking about a race. And in a race, you have first place, second place, third place. The order matters there. Or you might be talking about a password. So when you're dealing with a password, and let's say you have 4 letters in the password, the first letter has to come first. It can't just be in any random order. So the order matters. Or you could be talking about, let's say, floats in a parade. The first float would have to come first, and the second float has to come second. So the order of those things matter. So order matters in a permutation. The formula for permutation, it says P in R, where N is the items you have to choose from, and R is the number of items you're picking. Okay, so how many you need. And so in order to calculate this permutation, I can use the formula, and it says that I would take n factorial over n minus r factorial and simplify that. Permutation, order matters. In a combination, the order of the items does not matter. Okay, so order does not matter. So this would be like a committee of people, a committee of students. There's no president, vice president, and in that case it would be a permutation because president comes first, vice president comes second. But if I'm just choosing a committee, it doesn't matter how I pick the people. Or what if I'm putting toppings on an ice cream sundae? Does it matter how I put the toppings on the sundae? It does not. So this would be a combination. Order does not matter in a combination. So the formula, it looks similar. You'll notice we have a C for combination, and we still have an N and an R. And the N and the R, that's the same N and R. It's how many you have to choose from, okay? How many to choose from. And the R is still how many you need. So what happens in a combination is we actually take the permutation and then we divide it by how many we need. So it looks like this. So it's the permutation formula, and then we have to divide again by how many items we needed for that problem. So let's look at our first example. It's a permutation. So it says Deborah is choosing a 2-letter password from the letters A, B, C, and D. The password cannot have the password cannot have the letters repeated in it. How many such passwords are possible? So I know that this one is a permutation because the order matters. There's my keyword, password. It's a 2-letter password, so I need to choose 2 letters. And this is my bank of letters. There's A, B, C, and D, so there's 4 of those. So I have 4 to choose from. So my formula says that I'm supposed to take n factorial over n minus r factorial. So that would be 4 factorial because this is your n, here's your r, and then 4 minus 2 factorial. And 4 minus 2 factorial is 2 factorial. So if I were to write it out, it looks like 4 times 3 times 2 times 1 over 2 times 1, and those will divide out, and so I'm left with 4 times 3, and 4 times 3 is 12. So there are 12 different ways I can make this 2-letter password. This is a pretty simple problem. I could write them out. I could do AB, AC, AD. I could do BA, BC, BD, and so on. And you could list all of them, okay? Word problems involving permutations. What if your word problem involves a combination? How will you know? So let's look at this one. It says the coach of a softball team is holding tryouts and he can only take 2 more players for the team. There are, this one cut off, so let's say there are 8 trying out. How many different groups of 2 players could be chosen? So there's not a captain or a first place or a second place. We're just picking people on a team. The order that we pick the people doesn't matter. So that tells me it's a combination. And so I'm going to use my combination formula. Okay. So I have 8 kids that are trying out. So that means my N will be 8 because I'm going to have 8 kids to pick from. But I'm only going to take 2 players. So that's how many people I need. So my formula will be 8 factorial over 8 minus 2 factorial, 2 factorial. So that would be 8 factorial over 6 factorial, 2 factorial. And then I can write it out. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. And then another 2 factorial, 2 times 1. So I'll start dividing out numerator, denominator. So 6 divides with 6, 5 with 5, 4 with 4, 3 with 3, 2 with 2, 1 with 1. And those all make 1s up there. Okay, so my numerator, I have 8 times 7 times 1. 8 times 7 is 56. My denominator, these are all 1s down here now. I have 1 times 2 times 1, which is 2. And so then I take 56 divided by 2. So how many times will 2 go into 56? And so that would be 28. So there are 28 different player combinations I could pick.